This is simulated quantum gravity using our computational equation at Optimum Advanced Study, the same equation we use to generate simulated electromagnetism and the strong and weak nuclear forces, which makes it, to my knowledge, the first time that the four fundamental forces of physics have been simulated from one equation. This video is on a loop, as you can see, to isolate this particular phenomenon, but the simulation can be run indefinitely. So how does it work? I'll explain. The model you are seeing is called a continuous cellular automaton, and it was inspired in part by Dr. Stephen Wolfram, not his new physics project. Our model at Optimum went public over a year before Wolfram had announced his physics project, and I've heard that Wolfram's physics project was inspired by our work at Optimum, though I don't know that for sure. Rather, our model was inspired by Wolfram's book, A New Kind of Science, published in 2002. That book is also what inspired the Optimum logo, which is a procedurally generated infinite series of plus signs, because we are optimists, i.e. positive. The three plus signs hidden in our logo represent our three departments at Optimum: Optimum Advanced Study, Optimum Studios, and Optimum Athletics. Okay, Gary, so how does it work? I'll tell you. Every square, called a cell, that you see here contains a real number between positive infinity and negative infinity. Each number averages with each other number that directly touches it, and that happens in every cell simultaneously every time step. That's it. That's our unified equation. The word often used to explain such a simple equation that generates so much is elegant. And we didn't stumble on this equation by accident. This equation is simply the most elegant equation that can be used to model the deepest axioms of our universe: simultaneity, locality, symmetry, conservation, interaction, and continuity. Now you might be wondering, if the unified equation is simply simultaneously calculating continuous real number values on a matrix that interact locally and symmetrically so as to conserve their sum value, then where are you getting the colors and arrows, i.e. vectors? Good question. So those are derivative and are only there to help us better discern the underlying real number data. The deeper the red, the higher the real number density, and the vectors are simply pointing in the direction of greatest real number change. That's it. Now feel free to ask if you have any questions. Thanks.